Yes. So let us start. Comparison and differences between scalars and vector quantities. As we were discussing yesterday, the fundamental difference is all the physical quantities that you have in physics can be divided into these two categories, scalars and vectors. Those quantities which don't need direction to be described are called scalar quantities, and those quantities which need a direction also along with the magnitude are called vector quantities. Okay, so first difference is this. And let me complete one particular topic. You listen for 10-15 minutes, and once I ask you to raise any doubt, then you can ask your doubts. So listen completely. Most of the times it happens that any doubts any doubts that you get during my explanation, they will be solved by the end of my explanation, most of the doubts. But still, if you have any, you can raise your hand, or when I ask you to ask your questions, you can ask it then. So first is they have only magnitude, and vector quantities, they have both magnitude and direction. Both magnitude and direction. So without direction, we cannot describe that vector quantity as that quantity completely. Yes. And another, so this is like if you take a example to understand difference between scalars and vectors. Suppose I tell you that distance between Hyderabad and Vijayawada, okay, is let us say some 300 kilometers. 300 kilometers. Now you are in Hyderabad. I will tell you the distance to Vijayawada, 300 kilometers. Can you reach Vijayawada? No, you cannot. Because to reach Vijayawada, only distance is not sufficient. You need direction also. Okay, I should tell you that Vijayawada is 300 kilometers towards east of Hyderabad or towards south of Hyderabad, something, or southeast of Hyderabad. I must give you some direction also. Then you can reach Vijayawada from Hyderabad. So just this 300 kilometer is a scalar quantity. 300 kilometer towards east is a vector quantity. This 300 kilometer is magnitude of the physical quantity, and this east is the direction of that quantity. So in this situation, if I don't give you this direction, then the information is not conveyed completely. Okay, so that is how the basic difference between scalars and vectors is. Certain quantities, not all quantities, certain quantities require this direction also. Like we discussed examples yesterday, force, velocity, acceleration, these things, they need direction also to be explained completely. Okay. Another difference is between scalars and vectors. They obey rules of ordinary algebra. Ordinary algebra. What does this mean? This means, suppose I have 4 kg rice. If I add 2 kg more rice to it, I'll have 6 kg rice, right? Or I have 4 kg. Okay, so let us take the same thing, rice, and from that, if I take out 1 kg rice, I will be left with 3 kg rice. This is nothing new. This is already what you have been doing all the time in mathematics. 4 plus 2 is 6, 4 minus 1 is 3, minus 2 is minus 4, minus 2 plus 2 is 0. This is your regular ordinary algebra. And scalar quantities, they can be handled, or you can perform operations on scalar quantities with this regular algebra which you have been already using. There are no special rules to handle scalar quantities. Like if I add 2-meter distance to 6-meter distance, I'll get 8-meter distance. Okay. Or if I add 10-second time to 20-second time, I'll get 30-second time. If I add 10 degrees Celsius temperature to 12 degrees Celsius temperature, I'll get 22 degrees Celsius temperature. There is nothing special about adding or subtracting or multiplying scalar quantities. The same thing as we have been doing in our mathematics. But in vectors, if you do the same operations, you cannot apply the same regular algebraic rules for vectors. Here, to handle vectors, we have a set of separate rules which we call as vector algebra. They obey the rules of vector algebra. What are the rules of vector algebra? We will learn in our coming classes. Don't worry about that. There are certain rules for addition, subtraction, and multiplication of the vectors. We'll study all these rules in detail in our coming classes. Okay. To understand in a simple way, for now, if I take an example, I'll take example of a force. Force is a vector quantity. Okay. Let us say I have a body of some mass, and on this body I am applying a force of say 10 Newton in this direction. Okay. Another force which is also 10 Newton, okay, or 5 Newton in this direction. Then the total force acting on this body is 10 plus 5, which is 15 Newton. Okay, this is our regular addition. Nothing special about this. Fine. If I slightly change the situation, same body, 10 Newton force is acting in this direction, but the other 5 Newton force is acting in this
5
direction.
Newton. F net equals to 5 Newton, sir.
No, wait. Now, the total force acting or resultant force or net force acting on this body, now it is not 10 plus 5, but it is 10 minus 5, which is 5 Newton. Okay, because it is in opposite direction, I have to subtract it. Okay, this might also seem to be something familiar, but if you take this situation, same body, same 10 Newton force in this direction, the other 5 Newton force is in this direction. Now, the resultant force in this situation is neither 10 plus 5 nor 10 minus 5. It is something between 5 and 10. What is that something? You will understand it when we discuss the vector algebra rules. Okay, you have something called parallelogram law of vectors, which when applied to this situation will give you the resultant force. So you'll get something like root of 10 square plus 5 square. How you get this? We'll discuss this later. I'm just telling you now to understand how we handle quantities. Root of 10 square plus 5 square. You'll get some value. Okay, it is not 15, it is not 5. Some value between 5 and 10. Why is this difference? Because vectors have direction also. Scalars don't have any direction. You can just add them, subtract them using regular algebra. But while adding, subtracting vectors, you should keep in mind their direction also. Their sense of direction is also very important. So we apply special rules, special laws to add, subtract vectors, which we call vector algebra, rules of vector algebra. Okay, right. And we have taken examples already yesterday, but I will just repeat them here. Some common scalar quantities are mass is a scalar quantity, time is a scalar quantity, distance is a scalar quantity, speed is a scalar quantity, energy is a scalar quantity. Many things are there. And vectors, velocity is a vector quantity, acceleration is a vector, force is a vector, momentum is a vector. Many other things are there. Okay, right. Now, after understanding these differences between scalars and vectors, Harshavardhan.
So direction also is a vector quantity, sir.
Direction is not a vector quantity. Direction is not a physical quantity, no?
Okay, sir.
Sir,
Deepkriti Kumari.
Sir.
Actually, what is velocity?
No, don't go
Sir.
into these details. I'm just giving you names of the vector quantities. What is velocity? What is acceleration? What is force? What is momentum? We are going to study all these things in detail in our classes. I'm just giving you names of those quantities now.
Okay.
Soumya.
Sir, like you told that in the vector quantities,
Mm.
10 Newton force is applied.
Mm.
What is the exact quantity of a Newton?
We'll come to that point. If I just
Okay.
give you the definition, you can't understand now. We'll come
Okay.
slowly. Newton is a unit of measuring force, just like how you measure length in meters, time in seconds, mass in kg. Force is measured in Newton.
Okay, sir. Thank you.
Harshal.
Sir, can you tell again about the resultant force?
Resultant force in which case?
Sir, in this case, sir, third one.
Third one. To understand how you get the resultant, you need to know parallelogram law of vectors, which we'll study later in our coming classes. I have given here that example just to make you understand that 10 and 5 not always give 15 or 5. You can get 6, you can get 7, you can get 11, you can get 14 also.
Okay, sir.
Which number you get, it depends on the angle between the two forces. Right. Now, after understanding these basic differences between vector and scalar quantities, if you take a complete description of a scalar quantity, it can be defined like this. Vector quantity. So, a physical quantity which has both magnitude and direction. This is not complete definition of vector quantity. Many students stop here, like vector is a quantity which has both magnitude and direction. It is not complete description. Complete description is quantity which has both magnitude and direction, and which obeys vector laws of addition. Vector laws of addition is called a vector quantity.
Sir, subtraction also, no, sir?
There are no separate rules for subtraction in vector algebra. We use the same rules of addition.
Okay, sir.
So this is a complete description or definition of a vector quantity. Okay, right. Now, how do we represent a vector? How do we represent a vector? We, as vectors, have some special characteristic. What is it? Direction. Along with value, they have direction also. So we follow a special type of representation to show these vectors in writing or in printing. A representation of a vector. So always keep in mind vectors are special because they have direction. You should not forget direction of vectors. Wherever or whenever you are talking about vectors, you should be careful about its direction. If you forget direction, you will get wrong results while handling vectors.
So once can you scroll up?
So representation of a vector, we represent vector in two ways. One is in writing and the other is graphically. One representation is while writing. So if I want to convey, so let us say I have some physical quantity, which is say some velocity, acceleration, force, something, some vector quantity. I want to specify that it is a vector quantity. Like if A is a vector quantity, then it is represented in writing like A vector. A vector. You should read this as A vector or vector A. So read vector A. Some students read it like A bar. You get this bar in some chapter of mathematics. You apply the same here. It's not bar. Bar means something else. Bar means complement.
Sir, it's like when you get
reciprocal.
repeating decimal numbers, so you put a bar above the number.
That bar is different. That bar is not this thing. This is a different meaning. This arrow over the letter, which is used to represent a vector quantity,
So this represents a
indicates that
race.
this is a vector quantity. Arrow is a symbol for direction. So this arrow over the head of that letter or that symbol, it indicates that this particular quantity also has direction. And again, if I tell you direction, don't think that the direction of this vector quantity A is in this direction towards right side. It's not like that. That arrow does not represent any direction. That arrow simply represents that it is a vector quantity. It has direction. And what is that direction? We will represent. We have some other notation to represent it. We'll come to that. Okay. And while writing, and in some books, textbooks, vector quantities will be printed in bold or italics. In printing, vectors are printed in bold or in some books in italics also. That is possible in printing, but while writing, it's very difficult to write in bold or write in italics, no? So we follow this representation. If you want to specify that this particular quantity is a vector quantity, you simply write the symbol of that quantity. Like we use V for velocity, F for force, A for acceleration. So if I simply write F, this is a scalar quantity. If I put an arrow over this means this is force, this quantity is a vector. Similarly, V stands for velocity. If I don't put an arrow, it is speed. If I put an arrow, it becomes velocity.
So sir, anything so that is right with the direct the above arrow is a vector.
It is a vector
And the
quantity.
one that is without the arrow is a scalar.
Yes.
Sir, I have a doubt.
Hmm.
Sir, always they are represented with the arrow facing to the east, or according to the direction we change the arrow.
That's what I was telling you. This arrow is not used to specify the direction of that quantity. This arrow tells that it has direction, that's all. What is that direction? We have other method to represent it. Whatever might be the direction of that quantity, our arrow always points in the
Okay,
same
sir.
direction. This is in writing. Another representation that we use is graphical representation. Graphical. What is this graphical? We represent arrow vector quantities with arrows graphically. Graphically means not your XY graph, diagrammatically or pictorially. Graphically, vectors are represented by arrows. They're represented by arrows, like this. Arrow has got, what information does this arrow convey? It conveys
So it tells that it is traveling in
parts
the
of
single
information.
direction, sir.
One is the length of this arrow.
Depends on the
Length
distance.
of arrow
Arrow shows the magnitude.
represents magnitude of the physical quantity. Greater the length, greater the magnitude. Okay. And the other thing is this tip of the arrow. You call this as tip of the arrow. It
Indicates the direction.
represents, or it tells you the direction of that vector quantity. Direction. And this end, the starting end of the arrow, you call it as tail. Starting point of the arrow tail, and the arrow head, you call it as tip. Length of the arrow represents magnitude. For example, I want to show a displacement of 2 meters. So for that, I will draw a vector like this. This is a displacement of 2 meters in this direction towards right. Okay. If I want to show that the displacement is 4 meters in the same direction, then I should draw a arrow double its length like this, 4 meters. Or if I want to show a displacement of 2 meters in some other direction, the arrow will be something like this. This is 2 meter displacement in some other direction. This direction is different, this direction is different. Right? Like this, we show arrow vectors with arrows also. Tail of the arrow, tip of the arrow, length of the arrow. Length represents magnitude. Tip shows the direction.
Sir, what is A in writing, sir? A.
A is any vector quantity. Take it as force or velocity.
Smallest, sir.
Acceleration.
Acceleration.
Sir,
Yes.
sir, how do we represent acceleration, sir, in graphical?
Any vector is represented only by arrows. If I want to tell you that a car is getting accelerated by 2 meter per second square in east direction, I will show that like this. Acceleration is equal to 2 meter per second square. If the acceleration is 2 meter per second square in north direction, I will show it like this.
Okay, sir.
Right, representation in writing, graphical. In some situations we use in writing, in some situations we use graphical. You should be able to understand both representations. Okay. So what is a vector quantity? What is the necessity of vector quantities? Then how we represent vector quantities? Next is, what are the different types of vectors?
So what is acceleration?
It will take another 7-8 more classes to understand what is acceleration. Okay. Whatever I am telling here, whatever I am writing here, we will go into details of each and everything slowly, not at once. Because to understand acceleration, you should first of all know what is velocity. To understand velocity, you should know what is displacement. To understand displacement, you should know what is distance. All these things. It's a long story. There are no shortcuts.
So can you show graphical representation?
You just, if you're taking down the notes, just note down the important points. You need not write word by word, letter by letter, because it will be taking much time. You just note down the important points, that's all. Like what you call that, running notes.
Sir, can you once again explain about a graphical representation?
Graphical representation means instead of showing vector quantities by letters, instead of representing vector quantities by letters like A, B, C, D, or X, Y, Z, or P, Q, R, we show them with arrow marks. Suppose if I want to tell you that this is city A and this is city B. What is the direction of city B from city A? It is this. I should use an arrow.
Yes, sir.
The same thing we use in vectors also. Okay, types of vectors.
Okay.
There are different types, many types of vectors are there. We will take the frequently used or most commonly used types of vectors. First is equal vectors. Equal vectors. We say that two vectors are equal if they have same magnitude and direction. Both magnitude and direction must be same. Then those two vectors are equal vectors, like this. This is some vector P. This is some other vector Q. Their lengths are same and they are pointing in the same direction. Then they are equal vectors.
Sir, if the Q is tilted, is it not equal, sir?
Q,
If Q is a bit tilted,
if the direction is different, it is not equal. If either the magnitudes are different or directions are different or both are different, they are not equal vectors. Next. opposite vectors. Opposite vectors. So vectors which have same or different directions, sorry, same or different magnitudes. But opposite in direction. We call those vectors as opposite vectors. Okay, I'll take here, let us say we are taking displacement vector. Displacement, this is 2 meter displacement in this direction, this is also 2 meter displacement in the same direction. P is 2 meter in this direction, Q is 2 meter in this direction, same magnitude, same direction, same vectors, equal vectors. Now this is P, which is, let us say, 2 meter, and this is Q vector, which is 3 meter in the opposite direction. Their magnitudes are different, directions are opposite. Or you can also have P vector, which is 2 meter towards right, and Q vector, which is also 2 meter but towards left. These two are opposite vectors. Next.
Sir, I have a doubt.
Ah,
Sir, if both are in the same direction and their magnitude is different, then
unequal vectors.
equal vector, sir.
Unequal vectors.
Okay, sir. Sir, but you wrote in the definition same or different magnitudes, no, sir.
It is for opposite vectors.
Sir, can you explain opposite vectors again?
Opposite vectors, one train is going towards left, other train is going towards right. They are traveling in opposite directions, right? Similarly, if one vector is pointing towards right, another vector is pointing towards left, whether they have same magnitudes or different magnitudes, they will be called opposite vectors. The term itself specifies it, right? Opposite vectors, directions are opposite, that's all. Magnitude might be same, magnitude might be different. Next, collinear vectors.
Sir, once can you scroll up? Sir, sir, equal vectors means they always will have same magnitude in same direction.
Yes.
Can they be? Can we call two vectors equal vectors if they are parallel also, sir?
It means the same thing, no? Parallel means same direction, but their magnitude should also be same.
Okay, sir. That means if only parallel, we cannot tell they are same. Okay, sir.
Collinear vectors. Collinear vectors. We say that vectors are collinear if they
Sir?
act. Yes.
Sir, can I had one doubt, sir. If magnitudes are different, direction is same, sir.
If
magnitude is different, direction same, sir.
they are unequal vectors.
Okay, sir.
Okay, I will write that first here. Same direction but different magnitudes. This is vector P. This is vector Q. Direction is same, magnitudes are different. R. Same magnitude but different directions. This is vector P. This is vector Q. Lengths are same, directions are different. They are unequal. R.
Sir,
Yes.
sir, if the direction and magnitude both are different,
That's
then
what I'm
what
writing.
vector is it, sir?
That's what I'm writing here. That's why I told you, if you listen till the end, most of your doubts will get clarified automatically. Different magnitudes and different directions. Vector P is this.
Sir, opposite does not come under different directions.
They are also unequal vectors. Opposite vectors is a special case of unequal vectors. Two vectors which are opposite, they are unequal because they might be same or might not be same in magnitude, but their directions are different. So they are unequal vectors. Next. Collinear vectors.
Sir, can you scroll up?
Collinear vectors. So these are vectors which act along the same line. They act along the same line. Like, for example, this is vector P. This is vector Q. And this is vector R. These three vectors, they can have same or different magnitudes, but they should be acting in the same direction. Then we say that they are collinear vectors. Magnitudes might be same, magnitudes might be different. Next, coplanar vectors. Coplanar. Vectors which lie in the same plane. We call them as coplanar vectors. Co means same. Collinear, same line, same direction. Coplanar, same plane. What do you mean by this? If I take a XY coordinate system, this is x-axis, this is y-axis. In this XY plane, the region enclosed between these x and y axis, we call this as XY plane. In this XY plane, I have a vector P like this, another vector Q like this, another vector R like this. They can have same magnitudes, they can have different magnitudes, they can have same direction, they can have different direction. Whatever might be their magnitude and direction, but they all are lying in the same XY plane. And we call them as coplanar vectors. Then what are non-coplanar vectors? If I take
They lie in different planes, sir.
they lie in different planes. If I take XYZ coordinate axis like this is x-axis, this is y-axis, this is z-axis. Z-axis, x-axis is horizontal, left to right. Y-axis is vertical, top to bottom. Z-axis is into the plane and out of the plane, towards you and away from you. Third dimension. If I take a vector which is along x-axis, P, another vector which is along y-axis, Q, and another vector which is along z-axis, R, then these three, P, Q, and R, they are not in the same plane. So they are not coplanar. Coplanar vectors and non-coplanar vectors.
Sir, I have a doubt. Sir, if we take XYZ as a plane, then
XYZ
non-coplanar.
is not a plane. You can have XY plane, you can have YZ plane, you can have ZX plane. Plane is a surface, is a region which is bounded by only two surfaces.
Okay,
Your tabletop is a surface. Your entire table is not a surface.
You can imagine a room also.
Room is not a surface. Wall is a surface. Floor is a surface. Roof is a surface. Right. So these are 5 types of vectors. We have 3 more very important types of vectors. They are this position vector, unit vector, and null vector. These 3, they are very important. You should understand them in detail. Better we take it up in the next class because it's almost time.
Total how many vectors, sir?
If you have any questions, you can ask.
Sir, total how many vectors are there, sir? How many types of vectors?
Different types, you can have some 10 to 12 different types, but I'm telling you the most frequently used types. Navanitha. Yes.
Sir, in graphical vectors, how can we measure the magnitude of that?
It is not to scale. It is not to scale. It is not like you take a scale or measuring tape and draw that much length of arrow. It's not like that. Practically, it is not possible also. Suppose I want to show a displacement of 10 centimeter. I can draw an arrow like this. If I want to show a displacement of 10 kilometer, I cannot draw an arrow of 10 kilometer length, right? So it is just proportional, that's all, not to scale.
Okay. Sir, some students are raising their hands.
Who are they? Linisha, yes.
So in starting, you have given one example for the vectors, no, sir. By drawing a box, can you explain that thing once again, sir?
Drawing a box. What was that?
Sir, that is regarding vector algebra, sir.
Fourth, you told that
Yeah, you cannot add vectors like ordinary numbers. In mathematics, 10 plus 5 is always 15. But in vectors, 10 plus 5 can be 15, 10 plus 5 can be 5, 10 plus 5 can be 11, 10 plus 5 can be 6 also. How you get those different possibilities, you'll come to learn later.
Okay, sir, thank you.
Ritvik.
Sir, once can you revise opposite vectors?
Opposite vectors are simply 2 vectors which are opposite in direction, that's all. Name itself says opposite vectors. 2 people are traveling in opposite directions. 2 vectors are in opposite direction. They are opposite vectors.
But the magnitude will be same,
They
sir.
can be different or they can be same. Don't worry about magnitude. If just their directions are opposite, they are opposite vectors. Hansika. Okay, right. So we'll continue tomorrow. The other 3 types of vectors. Right. See you and good night.
Good night, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Bye, sir.
Bye, sir. Bye.
Students, please relax.